Problem number nine. Number nine. Number nine. An artillery shell, which means this is a dangerous problem. Kids, don't try this at home. All right, over here we have. Wait, we got to do this right correctly here. We got. What do we have here, everybody? Wait, I'll give you a clue. Purple Mountain's Majesty. All right, over here we have an artillery shell that is fired with an initial velocity of, somebody help me,
300 meters per second.
300 meters per second at an angle of
55 degrees.
theta equals 55 degrees. All right, so now we're only asked here for the x and y position after a certain amount of time. We're given the time. Well, let's write down what we have. Let's do the chart like we talked about. So we're going to say 300 meters per second, and theta is equal to 55 degrees. Bless you. All right, immortalized. All right, so now we're going to have our chart with x and y stuff. X and y. What is our x component of our initial velocity? Vx is equal to v naught cosine theta. All right, we'll get that later. V naught y is equal to v naught sine theta. Acceleration is our v naught. Acceleration in the x direction, 0. Acceleration in the y direction, negative g. All right, what else do we have? What else do we need? Delta. Yes, delta is what we're looking for, right? In both cases, we're looking for delta y and delta x. Delta y and delta x, the other way. All right, now this is not a typical projectile problem because we have 1, 2, we're looking for a third, but time is the bridge, but we're actually given time, aren't we? So for us, this is a super easy problem because we don't have to solve for t by using either the x or y and then plug it into the other. 42 seconds? Okay. Yeah, it sure is. That's in the air for a long time. All right, is it even possible? All right, taking a look, 300 meters per second at 55 degrees. So look, we don't have, as I said, we don't have to solve for either time in either the x or y, it's just given to us. So in each case, we've got v naught, we've got acceleration, we've got delta that we're looking for, we've got time. So for each the x and y dimension, what equation are we going to use? Meek-Grinder equation, both ways. All right, so let's take a look first at delta x. Delta x is going to be equal to Vx times t plus 1/2 ax t squared. Our gift. So all we got to do is say delta x is equal to v naught cosine theta, that's Vx, right? Times time, which is given to us. Delta x is equal to 300 meters per second times cosine of 55 times 7 seconds. Just kidding. All right, so delta x is equal to what, Remy? 7227 point what? 06, which we laugh at. And we say delta x, let's just say 7,200 meters. That's a more appropriate value given the sig figs that we have. Okay, 7,200 meters. So all we're saying is, it flies out here, that's 7,200 meters away where it hits Purple Mountain's Majesty. Okay? So now the other half of the question is going to be, how high on the mountain does it hit? What is our delta y here? Okay? So now all we got to do is exactly the same thing, except we're going to plug in all the y value stuff, all the y dimension parameters. So delta y is equal to v naught yt minus 1/2 gt squared. I've already substituted negative g for our ay, right? So delta y is going to be equal to v naught sine theta t minus 1/2 gt squared is equal to v naught, still 300 meters per second, times the sine of 55 times 42 seconds. This one's longer. Minus 1/2 9.8 meters per second squared times 42 seconds squared. And that gives us, I'm going to pick on you again, Ray.
1,677.
1,677 meters. Sir. All right. So we would call this, let's call it 1,700 meters. Right? If we're going to go with two sig figs, no worries if you had 1677, but please don't put 1677.021743386. All right. Everybody okay with this? Straightforward as you get.